We'll start with environmental chemistry by taking some small examples. So first we will talk about mole. So like we have the measurement of weight as kg, time as second, then distance as meter. Similarly, to measure the amount of substance, we have mole. And mole is defined as the amount of any substance which contains some 6.022 10 to the power 23 particles or ions or atoms or molecules. And this 6.022 or 23 into 10 to the power 23 is nothing but it's Avogadro's number, Avogadro's constant. So we can take an example. If we talk about 1 mole of oxygen atom, so it will be the molecular weight, which is 16 gram, means 6.022 10 to the power 23 particles. And if I talk about 1 mole of oxygen molecules, then its molecular weight will be 32 grams, which is also equivalent to 6.022 10 to the power 23 atoms. So how we can apply these calculations? So what is given in the question, that matters a lot. Let us suppose, for example, if I am provided with the weight of the substance and I have been asked to calculate the number of moles, so I will apply this like number of moles equal to given weight upon molecular weight. Or if it is the number of moles of atom, then given weight upon atomic weight. Another thing can be asked to calculate if I am given total number of atoms or total number of molecules. So number of moles can be calculated like total number of atoms or total number of molecules divided by Avogadro's number. So given this in our literature as an equation A or B, so given weight upon molecular weight is also number of moles calculation, which is also equal to the number of atoms by Na is equal to number of moles. So let us understand this with the help of a simple examples. So let us understand with the help of a question. We have been given a 5 gram of sugar, which is nothing but C6H12O6, which is glucose, and we have to calculate the number of moles and number of atoms. So first, if I have to calculate the number of moles and I have the given weight, how I will approach? I will apply the formula like number of moles is equal to given weight upon molecular weight. So molecular weight of the sugar will be 6 into the mass of carbon, which is 12. So 12 into 6 plus 12, which is 1 into 12 for hydrogen, plus 6 into 16 for oxygen. So it comes out to be 180 gram. So how we will calculate the moles? Because the given weight is 5 gram, that is divided by 180 grams per mole, which is the molecular weight of sugar. So it comes out to be 0.02 moles. Now the next question is how to calculate the number of atoms here. So we know we have 0.02 moles. So number of moles is also equal to the number of atoms or total number of atoms divided by Avogadro number or Na. So we can put up the number of moles on the left hand side, which is 0.02, which is equivalent to number of atoms divided by 6.022 10 to the power 23. This will give us the total number of atoms, which comes out to be 0.02 multiplied by 6.02 10 to the power 23, which comes out to be 0.12046 into 10 to the power 23 number of atoms. We can also see another example where we have to calculate the number of moles and number of atoms in 1.46 metric ton of aluminium. So 1 metric ton, as all of you know, is equal to 1 ton or 1000 kg, which correspond to 10 to the power 6 grams. So we know the weight for aluminium is 27 gram per mole or 27 gram per atom. So now we will be calculating it, that is 1.46 for metric ton. We will multiply this with 10 to the power 6 and then divide it by 27. So give us the number of moles, which come out to be 5.41 10 to the power 4. So now we can easily calculate the number of atoms also when we have the number of moles. So number of moles also equal total number of atoms by NA. So simply multiplying with the Avogadro number, it will give us the number of atoms. So it will be 32.58 into 10 to the power 27 atoms. Let's take another example where we have to calculate the number of moles when the number of atoms are 24.092 into 10 to the power 26 of oxygen. So we can apply the formula here, like we have been given the total number of atoms. So the number of moles of atom is equal to total number of atoms by N. So total number of atoms is 24.092 10 to the power 23 divided by 6.022 10 to the power 23, which gives us 4 moles. So you can try it by your own. So what is to be taken care here in such kind of question, that what exactly is given, what moles or the number of atoms. So accordingly we will apply the formula. Then what are the units of the things given in question? Does it need any conversion, whether it is given kilogram, tons or something? So we have to convert them into gram. And what all can be calculated and when it has been asked in the question. So if you keep these things in mind, you can easily calculate the things. Then the amount of solute present given quantity of solvent or solution is expressed in terms of concentration, and the concentration can be expressed in terms of molarity, normality, parts per million, parts per billion. So let's start with a very basic concept of molarity. So if we try to define molarity, molarity is nothing, it's number of moles of solute divided by volume of solution in liter, right, at a given temperature, which needs to be mentioned because molarity do vary with temperature and the units are moles per liter or molar. So now we have a question like calculate the molarity when 3 moles of HCl are dissolved in 200 ml of water. So first of all we need to convert this volume into the standard unit, which is liters. So 200 ml can be converted into liter by 200 divided by 1000. The number of moles are 3. So molarity is simply number of moles divided by volume in liters. So it will be 3 by 200. And this 200 needs to be converted into liters. 200 divided by 1000, which will come into numerator. So answer will come 15 molar. So the next question is question number 5, in which we have to calculate the molarity when 18 gram of NaOH is dissolved in 200 ml of water. So let's first of all calculate the number of moles of NaOH, which can be easily calculated. First we will calculate the molecular mass of NaOH. For sodium we have 23, for oxygen we have 16, followed by 1 for hydrogen. So the molecular weight of NaOH is 40 gram per mole. And the number of moles of NaOH can now easily be calculated. It's like 18, which is the given weight in gram, divided by 40 grams per mole. So number of moles for NaOH comes out to be 0.45 moles in this case. And then molarity can easily be calculated, which is 0.45 divided by 200, and then we have to convert this 200 ml into liter. So 1000 will go into numerator and it gives rise to 2.25 molar or moles per liter. Let's take another question where we have to calculate the number of moles, weight and number of atoms or NaCl present in 250 ml of 0.5 molar. So here what we have been given, 250 ml of solution and 0.5 molar. So in this we have to calculate the number of moles, weight and number of atoms. So the question is very simple as by definition. So we can apply like we have 0.5 molar, that must be equal to the number of moles divided by 250 ml converted into liters. So it will comes out to be 0.125. Then we can also calculate the weight with the help of moles, which is simple. Given weight upon molecular weight is equal to number of moles. So given weight will be molecular weight into number of moles, which comes out to be 7.25 gram. And if we have number of moles, then number of atoms can easily be calculated by multiplying with the Avogadro number, which is the third part. Now we will be talking about normality. Normality is basically another way of expressing the concentration of a solution. It is based on equivalent weight to gram equivalent. If we define normality, normality is nothing, it's the number of gram equivalent divided by volume of solution in liters. And number of gram equivalent is nothing, it is given weight upon equivalent weight, and equivalent weight is nothing, it is molecular weight upon Z factor. So this Z factor, or some people call it as X factor or K factor. So this Z factor is very important, and it is different for different base, acid, metals, non-metals, cations and anion. For any of the acid which can be dissociated completely, it is the number of H plus after the dissociation. For example, like HCl we have Z1, for H2SO4 we have 2, because they have respectively 1 and 2 hydrogen atom which can be ionized after dissociation. For any base, is the acidity of the base which can be dissociated completely in the number of OH ion after dissociation. For example, like NaOH, I have Z factor as 1 because it is having 1 OH. And there are some exception, like phosphoric acid H3PO4, phosphorus acid H3PO3, and hypophosphorus acid, which have been frequently asked in many of the examinations. For H3PO4 we take Z factor as 3, for H3PO3 we take Z factor as 2, and for H3PO2 we take Z factor as 1, because they have respectively 3, 2 and 1 ionizable or replaceable hydrogen atom. And both of these things, like normality and molarity, are interrelated. So we can see that normality is equal to molarity into Z factor. That can be taken into care. That is must. So normality is equal to molarity into Z factor. So normality is molarity into Z factor. So let's understand the concept with the help of a numerical. So we have to calculate the normality when 98 ml of H2SO4 is dissolved in 100 ml of solvent. So for example, like if we have taken water as a solvent, then gram is taken as milliliter and kg is taken in liter, because of the density of the water, which is 1000 kg per meter cube and 1 gram per cubic centimeter. So as all of us know that normality is equal to molarity into Z factor. For H2SO4 the molecular weight will be 98 gram and molarity will be number of moles over volume of solution in liter. So number of moles in that case, this case will be like 98 ml, which is more or less equivalent to 98 gram. Can be further reduced to moles, which is 1 mole. So molarity will be 1 upon 100 divided by 1000 to convert into liter. So 10 moles per liter molar. Normality is equal to 2 into molarity, because Z factor for H2SO4 is 2. So it comes out to be 20 normal. Another way can be like equivalent weight, which is like molecular weight upon Z factor, and gram equivalent is given weight upon equivalent weight. So molecular weight upon Z factor, like, so molecular weight for H2SO4 is 98 divided by Z factor, which is 2, comes out to be 49 gram. Then further gram equivalent can be calculated, which is given weight upon equivalent weight, and given weight is 98 and the equivalent weight is 49 for H2SO4, so 2 grams, and normality is equal to gram equivalent solute or volume of solution in liter, and gram equivalent comes out to be 2, which is volume of solution in liter, which is 100 by 1000. So again it comes out to be 20. So both the ways are correct. It depends upon the approach with which you do. Next question is calculate the normality of 0.1 mole HCl. So as you know that HCl is a monobasic, is having basicity as 1 and 1 ionizable hydrogen. So Z value for HCl will be 1. And we will apply normality is equal to molarity into Z factor. So 0.1 into 1, which gives you the answer as 0.1 normal. Now we have another important question with us. How to calculate the molarity of MgCl2 in seawater. Well, it is given that 0.54 molar is the concentration. So the first part is that how many gram of MgCl2 is dissolved in 100 ml of seawater, and what is the concentration of MgCl2 is expressed in millimoles per liter. So calculate